Okay, so we're just starting proofs. So we're going to practice having a statement that is just some statement of a geometry principle, like right here, and it's given to us. So the reason, and we are going to figure out if we can go ahead and where we can go next from that statement. So we're going to be referring back to this proof resource sheet repeatedly. This is the one that you guys have glued in your interactive student notebook. So there's general properties, segment properties, and then 2 pages of angle properties. All right, so let's look at what we have here. First of all, just by the symbols on number 1, we know that these are segments. Segment TO is congruent to segment AN. All right, there are no letters in common. If there were letters in common with each other, it would make me think potentially that we would have a segment bisector or a midpoint. If you guys see here, they would have AM congruent to MB, see how they have M in common, or PF congruent to FQ, see how they have F in common. So they didn't have any letters in common, so I'm going with it's not a midpoint and it's not a segment bisector. Looking down here on our segment addition postulate, that is just when we know a segment, we don't know anything about it, and it is using, if you look at what we'd have, we would either need to know B is between A and C, or we would need to know AB plus BC equals AC. We also definitely do not have perpendicular lines. It said nothing about being perpendicular. So there's no segment property it could be. So looking over here at general properties, the most common one that is used is definition of congruence. And what it lets us do is it lets us go from equals to congruent or congruent to equals. So I think it is definition of congruence. So what I would do, since we're congruent, we need to switch and say, okay, TO equals AN. And the reason is definition of congruence. And you can use symbols and abbreviations. And remember, when we do equals, we don't have the segment symbol. We do have the segment symbol when it's congruent. So we need to get better at that. All right, let's look at number 2. It says E is the midpoint of segment BD. So that definitely midpoint is a huge clue here that we're going to use definition of midpoint. And if you look right here on our example, it says M is the midpoint of AB. That's essentially what we have written, just with different letters. And then it says if and only if AM is congruent to MB. So this is where we can go from that statement, is writing something like this. So we're going to go ahead and we're going to switch back to worksheet 1. So it says E is the midpoint of BD. If you need to draw yourself a little sketch, so right here is E and it's the midpoint. So you can go ahead and you can see, okay, so then BE is congruent to ED. Now you cannot put equals because if you look back at this, the definition of midpoint specifically said AM is congruent to MB, so it has to be congruent. And our reason we're going to use is definition of midpoint. And so our key word there was midpoint, and that's what gave me the clue to go look for that. So definition of midpoint is the reason why that could happen. Okay, statement 3. A bisects CT. So once again, we have a huge clue word right here with bisects. So A bisects CT. If you go look at your resource page, here's your segment bisector. So it says if you have something that's the bisector of PQ, it could be a line, it could be a point, a ray, a plane, it doesn't really matter. But if you have it stated that it's the bisector of PQ at some point, then PF is congruent to FQ. So notice, once again, it let us say the two sides were congruent. It did not let us say the two sides were equal. So I could go ahead and make a little sketch in some spare room. So we have C, T, and A is the bisector. Therefore, it's halfway in between. So I can say that CA, the left side, is congruent to AT, the right side. And if you look at our reason, it was definition of segment bisector. So that's what I'm going to put down here is definition of segment bisect. And I'm just going to abbreviate. Okay, so look at this statement. CO equals OL. Now, because they have a letter in common, it really makes me want to be like, okay, So C, O would be right here, and E equals OL. So it makes me feel like O is a midpoint or a segment bisector, and it probably is. However, when we go back to our proof sheet and look at midpoint or bisector, we have congruent on both of these. We don't have equals. So if there was a congruent symbol, I could say, okay, hey, O is the midpoint because of definition midpoint. But there's not a congruent symbol. Ours has an equal symbol. So we can't use that because it has to be exactly the same. So the best option we have here, because if you look, it's definitely a segment. We can't use midpoint because it's congruent. We can't use bisect because it's congruent. It doesn't have any adding, so it's not segment addition postulate, and it said nothing about perpendicular lines. So that takes me back to the definition of congruence, which lets me go from congruent to equals or equals to congruent. So I can change the equals to congruent, but remember, you have to add the symbols back on. And that's definition of congruence. And I'm just going to use the congruent symbol. Okay, so on statement 5, we have angle DAY and YAK are a linear pair. What is the key word? All right, the key word is linear pair, and it's definitely angles. So let's go look at our angle resource page. So I'm just going to come down here and kind of clear off what we've written. All right, so if you look down here on your angles page, here's all your angles pages. Now we have linear pair written twice. We have two options here, definition of linear pair and linear pair postulate. So what we can do here is just kind of compare what we have in our facts. So if you look at your worksheet, it says the two angles are a linear pair. All right, and so right here, angle 1 and angle 2 form a linear pair. Then you can say that measure of angle 1 plus measure of angle 2 equals 180. So that's where I think we need to go, because we had a statement that said two angles form a linear pair, or they are a linear pair. So we can now go to the angle 1 plus angle 2 equals 180. Except we don't have angle 1 and angle 2. We have measure of angle DAY plus measure of angle YAK equals 180. And that was the linear pair postulate. And right now it feels like we have a whole bunch of crazy things here, but as we continue to practice, they will get better, and we will be able to quickly make more statements about this. We just have to get more familiar with our proofs, resources, and our reasons, and this is what this worksheet's doing. Okay, on number 6, what is the key word? Angle TOM is the supplement of angle SUE. All right, the key word is supplement, and we are angles, so we're going to go back to our angles page. All right, and so we are going to look for supplement. So I've got to scroll down a little bit to the bottom. Definition of supplementary angles. That definitely has our key word in it right here, supplement, supplementary. So if you know angle 1 and angle 2 are supplementary, then you can say measure of angle 1 plus the measure of angle 2 equals 180. Well, that's essentially what we know. We know two angles are supplementary, so we can say the measure of angle TOM plus the measure of angle SUE equals 180. And the reason there, if we look at the title, that was the definition of supplementary angles. So that is our reason. All right. So that pretty much covers our practice. You still have some more to do on this worksheet. And remember, it's day 1 of proofs. It's not going to be perfect the first time. We're just getting more used to all of our reasons. And once we get those reasons down, all of this will be a lot easier.